Hey there, folks. How's it going? Today, we are going to talk about oceanography. Oceanography is, well, the study of the oceans. Excuse me. And in your textbook, it takes up 2 chapters, and at least. And there is a lot of content in there. Oceanography can be not just an entire semester class, but a degree in and of itself. There's so much out there. So what I did is, instead of making this 2 PowerPoints, one for each chapter, probably still of great length, I made one decent-sized excuse me, conversation for us that pulls bits and pieces out of both of the primary chapters here. So, for those of you that enjoy reading the textbook, this is where the content's coming. When you start getting to something in the reading that doesn't sound like something we talked about in class, feel free to read through it, okay, skimming it, and ask any questions that you might have about it, but also, feel free to skim over it until you get to the next topic that we're talking about. And there's just, like I said, there's just so much. We got into some of it with the lab, or will get into it with lab, depending on whether or not you've done the oceanography lab yet. So some of the content that we don't talk about in lecture is covered in lab. So they do fit rather nicely together. Anyhow, without further ado, oceanography, study of the ocean. Your text likes to point out that it officially, in quotes officially, began with the HMS Challenger in 1872 when they set off on a 4-year journey to chart and navigate the oceans in a very official way. But, and I think you'll agree with me, like most sciences, I think since we've been thinking beings, we've been studying the ocean. Maybe not to the caliber and the rigor that we now consider science, but gosh, and if you know anything about history, we've been navigating the oceans way before 1872, and of course navigation took the stars into account, but there was also certainly aspects of the ocean that they had to be familiar with, aware with. So again, I personally always go back to the early observationalists of when we talk about the beginnings of science, but formally it's really not that old of a science. And you could understand the prohibitive nature, getting down into the depths of the ocean, of course, that we didn't have the technology for until much, much later in life. So what kinds of things do oceanographers think about? What do they study? Well, they could talk about the characteristics of the ocean water, how it got to where it is today. Has it always been like this? Where did it even come from? More specifically, someone who monitors current conditions of the ocean. They might be concerned with properties like salinity and temperature. All right, if you pay any attention to the whole climate change issue, all right, salinity and temperature are big factors in how this is all going to play out. The ocean currents, which again we don't really touch on in lecture here, play a large part in controlling the weather. And temperature and salinity affect the currents. So very important stuff. Also the life in the water, the organisms, which we will talk about in this lecture, both the critters and the plants. My favorite part, the beach. Okay. Oceanographers can study the interactions at the shoreline. And then, of course, oceanographers, the ones with the really cool jobs, I suppose, if you could handle being in a submarine, they get to study what's going on way down on the ocean floor. And there's a bit of that in here as well. So let's talk about what most of you think of when you first think of the ocean. If it's not the beach, you think of the salt water. Okay. And if you've ever had a mouthful of ocean, you probably know that it doesn't taste like, if you've ever had the unpleasant directive from your doctor to gargle with salt water, okay, you realize the two don't taste the same. And yeah, you can say it's all the fish pee and the pollution and this, that, and the other. And, you're right. It makes the ocean taste a little different. But the biggest difference is that, of course, it's not just salt, as in sodium chloride, that's in there. Okay, there certainly is sodium chloride. But there's other things that we call salts that are in there. That's a chemistry term, okay? Sodium bicarbonate, which you might be familiar with. Potassium nitrate, magnesium sulfate. Those are the big four, okay? But so the salinity doesn't refer just to the salt content, as you know, salt, but there's lots of other factors involved. As I implied on one of the previous slides, salinity can vary. Scientists break down water into 4 big categories. Okay, fresh water, brackish water, saline water, and brine water. Okay, fresh water has little to no salt content in it at all. That's what you drink inland. There's very few saltwater bodies inland. There are some, certainly some. Brackish water is approaching ocean water, marine water, saline water in its saltiness. Brackish water is a mix of fresh and ocean waters. Okay, so you find these by the land where, let's say, a river is emptying into the ocean, and you get that mixture of fresh and salt water, which dilutes the salt content, understandably. Then you have your salt water, which is just your average ocean there. And then above and beyond that, you've got super salty, which is brine water. Some of you might be familiar with brining a turkey, okay, or something else. What it's referring to is the high salt content in there. Oftentimes, I think some vinegar too when they refer to like brining pickles. But nonetheless, in here, we're talking about extra salty water. You may have heard of some seas that are so salty you can float extra good in them. Dead Sea comes to mind. And actually Salt Lake in Utah, which I had the pleasure of visiting recently, it's funky. You definitely can feel a difference. But that's not common environment, okay? The oceans themselves fall under this saline, and you see where it is 30 to 50. The PPT stands for parts per thousand, all right? And so if you were to take a bottle that contained 1,000 pieces of water, if you would, 30 to 50 of those would be one of the salts that we mentioned on the previous page. Okay. I apologize, this can't get bigger. I could turn the picture sideways, which I've done in the past, actually. It only makes the text slightly bigger. So, and it's sideways, but it's a neat little graphic. All right, now I want to spend some time talking about some areas that you are, if you're familiar at all with the ocean, these are areas that you are familiar with. Okay, it's always nice to start off with the familiar. I want to talk about estuaries, the intertidal zone, seagrass beds, kelp forests, and coral reefs. Now, again, you've probably heard of some of those and have an idea of what some of those are already. Maybe some you haven't heard of. So let's dig in. So estuaries are great examples of that brackish environment that we just talked about. All right, where a inland body of water at the coast opens out to the ocean. All right, this works best. It says partially surrounded by land. Picture a bay. Okay, this works best if you kind of have a mixing bowl, if you would. Chesapeake Bay is a great example. But, even if it's not enclosed, you'll just have a much smaller area. Some of you folks around here might be familiar with the St. Lawrence Seaway. Okay. There is an area of the St. Lawrence where, the salt water comes in, mixes with the fresh water. Okay. And you get that estuarine environment that way as well. But typically, like I said, Chesapeake Bay is a pretty stereotypical example, but there's tons. So this is more or less what we've just talked about. Obviously, the salinity would increase as you get further out into the bay. These are amazing environments for humans with regard to foods, okay? Be it even, animals come to mind, of course, but even some plants that we really rely on that grow in these types of environments. As you could imagine, they're relatively shallow water because we're talking about basically at the coastline. And you'll see here in a moment that they're usually fairly well vegetated as well. And that's important for the food. Think of the little critters. These are the nesting grounds. Many organisms are born and grow up in these areas and then move out to the deeper waters. And then of course, we love our shellfish, right? Many of us at any rate. Without these kinds of areas, and even fish, the spawning grounds and so on and so forth, that they're just vital. So two kinds of estuaries I'd like to talk about, and I conjugated this a minute ago. I said estuarine. All right, same idea. Usually in science, if like 75% of the word is the same, it's probably just being conjugated. It means some version of whatever the majority of that word means. So scientists love to do that. They'll conjugate freely. I'm guilty of that myself many times. So you'll see estuar, and then a bunch of different endings on it. Anyhow, salt marsh and mangrove. Okay, salt marshes. If you've been to the southeast, anywhere along the coastline, Outer Banks, or anywhere, all those sandbars from Jersey downwards, you've probably come across a salt marsh. They've got them up in Massachusetts as well. I shouldn't just say Jersey, but and probably north of Massachusetts. I've not been up that far, but I've definitely been from Massachusetts all the way down, most of the way down, and we've got salt marshes all along there. Mangroves, it's a little different. It's a tropical version, and you'll see well, there it is. Mangrove is a tree. So you've seen these in television. They love to have boat chases through mangrove swamps. So, all right. So salt marsh. See that? You've seen those if you've been to the beach and ever left the sand in the boardwalk area. These grasses, you probably also noticed, we see in one picture here and another picture. These are different areas, but the effect is the same. These areas are definitely affected by the tides, okay? And something that might look along this line at high tide. When the tide goes out, it'll drain significantly, and that's when the birds come in and start picking around and so on and so forth. This is not me, but those are my children. They had a great opportunity a ways back. One of the places we love to go, the wife and I, is Chincoteague, Virginia. It's where the wild horses are. And my wife gave us the opportunity to go out with one of these locals who do the boat tours, and he had a blast with the kids. We had a blast watching them, and so it was a very awesome opportunity to see, get out and, in the middle of what you usually just see from the shoreline. So salt marsh, mangrove. See, now they look familiar. Okay. Usually you see a big fan boat jetting by these things. This picture happens to just be from one in Puerto Rico. I didn't go there. I grabbed it from the internet. But so they always say tropical, but I'm almost positive they've got some very similar areas in like Florida, Georgia, Louisiana. Okay, southern coastal areas. It might just be a different species, or a species of mangrove, or a completely different species. Genus and species, different plant that behaves in the same manner. But I swear I've seen, some places that were supposedly in Florida. Again, maybe it's just Hollywood being Hollywood. But I have mucked through the Okefenokee swamp, slightly different down there, but not mangroves, I don't believe. So anyhow, typically they consider these tropical. My favorite, the Intertidal Zone. This is the beach, okay, along the shoreline. Life within the tide zone is very, very tough. I'm one of the few people that when I get to the beach, I'm looking down instead of around at all the pretty people there. I'm watching the little clams that tunnel back in every time they get sand above them washed away. I'm watching the birds come down and try to grab one of those little clams or crabs before they can hide again. It's a rough life. As you know, if you've been on a more natural beach, it's a mixture of rocks and sand. So if you are unlucky enough to be just floating around out there, again, as a critter, even a plant, it's a tough life. It's what we call a very high energy environment. Okay. If you've ever wondered why those clam shells are so hard, okay, it's because, they get beat around a lot. Not just, rock into rock, but even that water continually bashing into you is a tough life. Now, I've not been lucky enough yet to get to beaches with starfishes. That's one of my goals in life. But again, on TV, or some of you maybe in person, have seen these tidal pools exposed. Okay, we've got some look like mussels in the background there. But the starfish and sand dollars, I've yet to see those in real life. Hopefully someday. But it's exactly, what you'd expect. And then, of course, the beach proper. All right, so this is, probably a good bit inland, but not too far, because these starfish, they were underwater when they got here. So you're still within the tidal zone, but probably not right down in the splash, the splash area. So. All right, I am going to stop here and start another video. Again, trying to keep these in the 15 to 20 minute segments.